Hi everyone, welcome to video 4-3. In this lesson we're going to be talking about parallel lines again, but specifically we're going to be talking about ways in which we can prove that two lines are parallel, and you can see that's our essential question here at the beginning of the lesson. We're going to be first exploring the idea of what a converse is. So when we form a converse of an if-then statement, if P then Q, we simply swap the locations in the sentence itself of P and Q. So basically the initial, what's called the hypothesis of that conditional statement becomes the conclusion, and the conclusion becomes the hypothesis. So it's basically taking the logic and turning it on its head and reasoning in the opposite direction. Okay. So what we're going to do is a little exploration here. We have a diagram over to the right hand side over here with two lines and a transversal. Notice they're not marked with any kind of parallel marking for L and M, so we're not sure we can assume that or not. We're going to try and explore some different ways to talk about that. So the statement boxes that you have here are basically, this is like our word bank right here for the fill-ins for A through D. And we're going to see kind of what we need to fill in as we go. Okay? All right, so first off, it says use two of the given statements together to complete a statement about the diagram using the same side interior angles postulate. Okay, so the same side interior angles postulate, remember, is we're actually calling same side interior angles theorem. We have that switch in names from the last couple of sections also in effect in this section. So by that postulate, it says if the first thing is lines in this particular diagram, the two lines that we might assume would be parallel would be lines L and M are parallel. And remember, we'll use our symbol for parallel there just to simplify our writing there. Then what would be true is, well, again, where are my same side interior angles? It says 6 and something else. So what is a same side interior angle with number 6? Same side, but inside the parallel lines would have to be 3. So we'll fill in 3 here, and we'll fill in 3 up in our word bank. Now we're going to take that same logic where if the lines are parallel, then the angles are supplementary, and we're going to turn it on its head. So by its converse, we're switching like the P and the Q locations of the parts of that statement. So by its converse, the second part, what followed the then, is going to be the if. So if I start by saying that angle 6 and angle 3 are supplementary, then what we can conclude is that lines L and M are parallel. So again, we're starting with knowledge about the angles instead of about the lines in this section. In part C, we use the same diagram, but this time we're using the alternate interior angles theorem, and then we're going to write its converse. So first of all, by the theorem, where are my alternate interior angles? It says if, first off, we're starting that we know lines L and M are parallel. Those are parallel lines, sorry, stylus issues. Then angle 4 is congruent to what? Well, where's 4? 4 is right here. And an alternate interior angle with 4 would be angle 6, remember. So we're going to say angle 4 and angle 6, and we'll also fill it in up in our word bank. Okay. So again, first we have the if, then the then, and then in the converse, we're going to flip those two statements around. So if now is the knowledge about the angles. If angle 4 is congruent to angle 6, then we can make a conclusion about the lines being parallel. And then finally, one other final statement, you can probably guess, we've talked about same side interior angles, we've talked about alternate interior angles. Another one of our theorems has to do with corresponding angles, as you can see here. So it says use the diagram and the given statements to illustrate the corresponding angles theorem and its converse. So by this theorem, if we have corresponding angles, okay, but first we're starting with, do we know if the lines L and M are indeed parallel, then angle what is congruent to angle 7? Back up on the diagram, where is angle 7? Angle 7 appears to be in that southeast corner of the bottom cluster of angles, so we want the one in the bottom corner of the cluster of angles, bottom southeast corner, so that's angle 3 of the top cluster of angles, and so angle 3 is congruent to angle 7. When we write the converse of that statement, we very simply just put if first. Of course, we always start our conditional with if, but this time we start with knowledge about angle 3 being congruent to angle 7, and then we can say L and M are parallel. Okay, so this is just using the logic in reverse. And now we're going to skip ahead over to the next page. And you guys, here I am on page 186, Explain 1. And we are talking about the different converse theorems that we might be coming across. First of all, converse of the same side interior angles theorem, rename that one so that it goes with the rest of the ones that we've talked about changing. And that says if two lines are cut by a transversal so that a pair of same side interior angles are supplementary, which is the relationship that we know is held as true if the lines are parallel, here in the converse we're reversing it. So if we start by knowing the angles are supplementary, same side interior angles, then the lines are parallel. Same thing with alternate interior angles. What's the relationship that we know? We know that if alternate interior angles are congruent, then we can reason from that that the lines are parallel. And then finally, corresponding angles. This is the converse of the corresponding angles postulate, and that is that if two lines are cut by a transversal, even if we don't know whether the lines themselves are parallel, if those corresponding angles are congruent, then they have to be. Okay, so that's the way the logic is working here. So let's reason through this example 1 here, parts A and B, and you'll get an idea of what you need to do for your turn 4 and 5 first off for your own work. Example 1, it says, so the mosaic designer is using a quadrilateral shaped colored tiles to make a tile design on the floor, and each tile is congruent to the one shown here. So we have our picture and we have some angle measures that are given to us, and so you can see how they're laid end to end here. Okay, what's a little difficult to see in part A is that this is actually two tiles together right here. So it says use the value of the marked angles to show that the two lines L and L1 and L2 are parallel. What we know is that the measure of angle 1 in the upper left-hand corner of our quadrilateral tile is 120 degrees in that same spot there, and that the measure of angle 2 down in the bottom left-hand corner is corresponding to that 60 degree spot there. And because angle 1 and angle 2 are adding up to 180 degrees, they are supplementary. And so if I have two supplementary angles that are on the same side of my transversal, and we're considering this blue line like the transversal, then we can assume that the lines are parallel by that converse theorem. Okay? So on the top of the next page, we have the same situation, but notice where the tiles are laid this time. And we're being asked to kind of use the values that are marked here, angle 1 and angle 2, to see what the relationship might be, and therefore what is true about lines L1 and L2. So the measure of angle 1 is still that large 120 degree obtuse angle using the same measurements as on page 186, okay? And then the measure of angle 2 is also 120 degrees. And the relationship between the two angles is that they are congruent corresponding angles. These two tiles here are in have angles marked in corresponding spots. So we have our northwest corner and our northwest corner here that are the same exact size, and therefore the conclusion is that L1 is parallel to L2, and as you write your turn here in the next couple minutes for number 4 and 5, you want to make sure you not only write that the lines are parallel, but what exact theorem actually told you that. And we're just referring back to page 186 there. So I'll model that for you right now. Not only is L1 parallel to L2, but we would say that that is true by, and here's our converses coming in again in this section, by the converse of, well, what angles were they? They were corresponding. So it's the converse of the corresponding angles postulate. So just wanted to get you in the habit that when you get down to our your turns here for 4 and 5, we'll be doing the same idea as what we just did in example 1, part A and B. We'll be explaining why the lines are parallel. Notice we have the same tile shape as we had before, and not only explain why they're parallel, but actually give the name of the theorem. That's what the explanation is, basically. So when you have this on an assessment, that's what you will be asked to do, is identify which of the theorems tell you that, basically. And we will, of course, allow you to have that list of the theorems that is linked on your outline in front of you for the assessment. So no worries about having to memorize all of those verbatim or anything like that. So take a pause on the video here and do 4 and 5. Okay, on the next part of the video, we're going to skip over explain 2 for now, but let's just talk about the page. This is constructing, meaning with a compass and a straight edge constructions. And I do have a separate video, you guys, linked off of our outline here for you that refers back to our HMH resource videos, where you can just kind of watch the process of that parallel line construction, and then we'll be doing that together when we're in class. So we're going to skip over explain 2 for now. If you want to pre-read through these steps, can't be a bad thing at all. It's pretty straightforward using a copying and angle construction like we did before. But we're going to go ahead and jump now to explain 3. So for explain 3, we are going to be not only verifying that the lines are parallel, but actually maybe doing some algebra and proving that that is the case. Okay. So in explain 3, it says when two lines are cut by a transversal, we can use those relationships of the pairs of angles, that means corresponding, same side interior, alternate interior, etc., to decide whether the lines are parallel or not. So here's what we're given in part A of example 3. It says use the given angle relationship to decide whether the lines are parallel. We are told that 3 is congruent to 5. So the question is, are 3 and 5 any special pair of angles, and does the fact that they are congruent help us out at all? Well, of course it does. We can identify that 3 and 5, okay, are congruent alternate interior angles. And so the question is, are the lines parallel? Yes, because the converse of the alternate interior angles theorem says that if I have two congruent alternate interior angles, then the lines that they are formed from are also parallel. In part B, here's the information that we have here, and it might help to put this on the diagram. So for part B, we're told that the measure of angle 4 is x plus 20. That's this spot right here, degrees, and that the measure of angle 8 is 2x plus 5. So if those two angles are labeled with x plus 20 and 2x plus 5, the question is, and we're told that x is actually equal to 15, is there a relationship that holds true that proves these lines are parallel? So first thing we want to do is probably identify what is the numerical measure of the angles. So the measure of angle 4 being x plus 20 when x is 15, substituted in, gives us that that's 35 degrees. And the measure of angle 8 when x is 15, substituted in for x, gives us also 35 degrees. So that tells us that angle 4 and angle 8 are congruent, and notice their locations. What's their name? This is the southwest and southwest corner of each cluster of angles, so those are compass points. Compass points are corresponding. They are congruent, corresponding angles. So are the lines parallel? Yes, of course they are. And why is that? By, here's this idea again of justifying the reason, okay, by the converse, always converse when we're in this section, of, and that is the corresponding angles postulate. So on the next page, page 190, right at the top here, you're going to be working on your turns 8 and 9 using this diagram over here. And notice we don't have parallel markings, but we're given some initial conditions, different initial conditions each time for 8 and 9. And so we're asked, can we, from the initial information that we have, in each case, determine whether the lines are parallel, yes or no? And if the answer is yes, make sure that you're also giving the name of your postulate or theorem that justifies it. Okay? So that's it for video 4.3, and we will see you guys next time.